All right, good evening. These are just some more examples on classifying conic sections. It's extremely important that you understand the subtle differences between the four conic sections. So like I said, take a look at how the different conics are written. So if we're looking at our first problem, a few observations. Notice that I have both an x squared and a y squared. Because I have both terms that are being squared, I know that it is not a parabola. Another observation. Notice that our two squared terms are both on the same side of the equation, and when they're on the same side of the equation, they are both positive, which means that they are not going to produce a hyperbola. So that means the other two options that I have are a circle or an ellipse. Now, whenever the coefficient is the same for both squared terms, it's going to produce a circle. And the reason that's occurring is because essentially they're being stretched an equidistant both vertically and horizontally. So our first problem does produce a circle. Okay? If you'd like to go into more detail, you're going to notice the fact that it has a center at the origin. If we're looking at equation 3, we can use some similar logic. Notice that everything is set equal to 1, so it is currently in that standard form. All or both my squared terms are on the left-hand side of my equation, so I can proceed. Both terms are present that are being squared, so I know it's not a parabola. I also notice that both of my squared terms are both positive, so neither are being subtracted, so it's not a hyperbola. Now the coefficient for x squared is essentially a coefficient of 1/9. And the coefficient for y squared is essentially a coefficient of 1/16. And because they have different coefficients, this actually means that it's being stretched in one direction more than the other, which is going to produce an ellipse. Okay. All right, let's look at a different one. Let's look at number 5. Number 5, notice that we have this quantity here of y being squared, but the x is not squared, and there's nowhere in this equation an x being squared. So this tells me that's going to be a parabola, okay? If you'd like to go into more detail regarding this one, because the y is being squared, I know it will be horizontal. And because my a value here is positive 1, I know I'm going to open to the right. If you want to go into even more details with this one, the vertex for this parabola is located at -2, -4. Because remember, with horizontal parabolas, the vertex location is kind of flip-flopped. All right, looking at all these, so far we've identified 3 of the 4 conic sections. Which of the remaining problems is a hyperbola? I'm going to let you think about that before I give you the answer. So if you need to pause, go ahead and pause me. Looking at our remaining options, 7, 2, 4, 6, and 8, the only one that is possible to be a hyperbola is number 6, because both squared terms are on the same side of the equation, and one of them is being subtracted, okay? Notice that key phrase that they're on the same side of the equation, and only one of them is being subtracted, okay? All right, so here's some beginners, just looking at standard form. In a second, we're going to take a look at ones that are in that general form, because in general, they don't tell us a whole lot of information. All right, so now we're going to do this a few more times. Notice that in all of these examples, they are set equal to 0. Because they are set equal to 0, that means I can make a judgment just by looking at one side of the equation as to what type of conic section I am looking at. So if we're looking at, let's look at number 10. Let's look at the even problems. Notice that I have a y being squared, and that's all that's being squared. This tells me that I have a parabola on my hands here. If we're looking at number 12, notice I have 2 squared terms, which means that it's not a parabola. Then we also notice that both of them are positive, so therefore they're not being subtracted, so it's not a hyperbola. Also, both of the coefficients for the squared terms are the same, producing a circle. Okay. Please note the thought process that I'm going through in order to identify the conic sections. Let's jump over to the odds. Let's look at number 15 here. Notice that I have 2 squared terms, okay? And also notice that subtly the x squared term here is being subtracted because it is a negative. Because one of them is negative and one of them is positive, this tells me I'm actually going to have a hyperbola on my hands here, okay? And I'm able to make that judgment because both squared terms are on the same side of the equation. In any of these problems, do you have an ellipse? Let you think about that for just a second here. So 9, 11, 13, 14, and 16, do you see an ellipse? I do not see an ellipse because I do not see the qualities of two terms being squared, both terms are added, and both have the same coefficient. None of these meet their requirements, okay? If you are still struggling with classifying conic sections, let me suggest that you look into identifying a flowchart. If you Google classifying conics flowchart, I'm sure you will find a really wonderful resource.